We now continue with question 7, which reads, express in partial fractions, hence evaluate the integral shown. To express this in terms of partial fractions, the denominator is a quadratic that has been factorized and has linear factors. So this will be identical to a over x plus 1 plus b over x plus 3. Multiplying both sides by the denominator of the left hand side, we have 5x minus 3 to be equal to a into x plus 3 plus b into x plus 1. Now when x is equal to minus 3, we have b to be equal to 9. And when x is equal to minus 1, a will be equal to minus 4. Therefore, f of x becomes minus 4 on x plus 1 plus 9 on x plus 3 in partial fractions. Evaluating that integral, since it's already in partial fractions and the word hence has been used, so we continue with this answer that we have in the previous part. And when we integrate this, we have the integral minus 4 in x plus 1 plus 9 in x plus 3. Note, you have to use the absolute value signs because this integral will be undefined if it takes a value of 0. If the ln function inside occupies or takes a value of 0, it will be undefined. So you have to use the absolute value signs. And this integral gives us 0.967 to 3 decimal places. Don't forget to click on the subscription button, and you can visit our site on gcemathpanel.blogspot.com and stay tuned for other papers that will be coming in. The next part of the question reads, given f of x equals that and taking 1.5 as the first approximation to that equation, use the Newton-Raphson procedure to obtain to 3 decimal places a second approximation to the equation. Here the first root is denoted x0, where x0 is 1.5, and this is the first root or the first approximation. We now have to look for f of 1 using the equation that has been given, and we have approximately 0.351. Then we look for the integral, the derivative of f of x. We look for the derivative, and this derivative gives us 10x minus 2 on root x. F prime of 0 using this derivative gives us 13.367. And to use the Newton-Raphson procedure to obtain the second root, this note, the second root here is denoted x1. The second root will be given by the equation x1 equals x0 minus f of x0 on f prime of x0. We put in these values you have already obtained above and simplify, and this gives us a value of 1.473, and as the question stipulates, to 3 decimal places. Thank you so much, and stay tuned as we proceed to question 8. Thank you so much. I have been Evina, presenting at the GCE Math Panel. Bye bye.